Hi, everyone. Welcome and thank you for joining us today. I'm Itzik Rosenberg, CTO at Atlantium Technologies, and I will be your moderators for today's session. We are excited to have you here. Over 20 years, we have been pioneers in advanced water treatment with our proprietary HOD UV technology, taking critical water quality challenges, including emerging contaminants. Today, we'll showcase how Enspired Solutions integrated Atlantium HOD UV technology to provide on-site PFAS destruction. As many of you know, only a small portion of Earth's water is safe from consumption. Technology is the only way for ensuring global access to safe water. Our solutions focus on eliminating pollutants rather than capturing or sorbing them, which only transfer the problem from one place to the other. We put all our efforts in finding ways to solve the problem by using HOD UV light. UV light is a viable tool for photodecomposition of pollutants while generating germicidal and photochemistry power by direct photolysis or in a combination with dedicated additives. Atlantium is currently active in providing solutions for such needs, such as NDMA, 1,4-dioxane, TCE, and others. Now let's talk about PFAS, also known as forever chemicals. These chemicals are resistant to breakdown and persist in the environment. Atlantium has teamed up with Enspired Solutions to provide highly sophisticated solution to eliminate PFAS. Effective PFAS destruction with UV requires consideration of the specific water characteristics, the target power, and the light spectrum. Optimizing for these aspects ensure the system delivers maximum effectiveness in addressing PFAS contamination. Now I would like to introduce Enspired Solutions. This women-led company is at the forefront of PFAS destruction innovation. Please welcome CEO and co-founder on Enspired, Denise Key, and Chief Operations Officer, Sarah Mayer. Denise, the floor is yours.
Hi, I'm Denise. Thank you, Itzhak, and thanks to Atlantium for arranging and hosting this webinar. Thanks also to each of you for spending some of your time with us today. We hope to provide you with some useful information for solving your PFAS challenges, and we would also like to learn a little from you too. So please scan the QR code and indicate the water matrix you most frequently work with. You will need to scroll to the bottom of the selections to submit your answer, and we'll show the survey outcome on screen. It looks like industrial wastewater is leading, with drinking water not far behind. Groundwater contaminant is pretty significant too. Thank you. That's a great indication and very helpful to us. So Sarah, would you help us continue with the presentation?
Yeah, thanks, Denise. Hi, everyone. I'm Sarah. It's great to be with you today on this webinar. I'm going to start by building on what Itzhak started with today. PFAS, they're referred to as forever chemicals because they don't naturally break down in the environment. And the rising amount in our global water resources has resulted in 95% of us having detectable levels of PFAS in our blood. There are many routes for PFAS to get into the environment, and human exposure comes through water, food, and convenient household products. Unfortunately, PFAS exposure is now linked to negative reproductive outcomes and multiple types of cancer.
With the increasing regulation and growing awareness of risks posed by PFAS, companies contributing to environmental releases are facing substantial costs. Fines and litigation settlements related to PFAS pollution are frequently in the news these days, with costs ranging from millions to actually billions of dollars.
Current methods to manage PFAS in water effectively really just push it around or move it around, capturing it on filter media and disposing of it in ways that can risk re-releasing a portion back into the environment. Inspired Solutions innovation is equipment and chemistry that allow PFAS in water to be broken down into non-toxic discharge on site. At the heart of the system is Atlantium's HOD UV technology, catalyzing a reductive defluorination reaction.
So this is how it works. In the first panel, the blue dots represent PFAS. When PFAS contaminated water enters the system, liquid reagents are mixed in and form a reactive cage, isolating the PFAS molecules. Atlantium HOD UV triggers a reductive defluorination reaction. The system is not pressurized and it is not heated. This results in harmless byproducts, including fluoride, water, and simple non-toxic compounds. And by the way, we can monitor the destruction reaction in progress in real time by measuring the production of these fluoride ions. And we're recognized. Inspired's chemistry has won an award from US EPA and Department of Defense by meeting their criteria for PFAS destruction and energy efficiency. We call our total solution the PFASigator. The PFASigator is modular automated equipment and the patented chemical reactions that occur within the equipment. This is me and my co-founder, Meng Wang, with our first commercial scale PFASigator. The PFASigator is a batch reactor. Concentrated PFAS solution enters the reactor and liquid reagents are mixed in. The batch is circulated through the HOD UV light system while fluoride is monitored as a real-time indicator of PFAS destruction. When the targeted level of destruction is obtained, the treated solution is discharged back to the waste treatment system. PFASigator has comprehensive process monitoring and control to ensure reliable operation. The real-time fluoride measurement confirms the PFAS mineralization. The UV lamp sensor ensures efficient HOD UV functionality. And there is automatic reagent dosing, along with remote monitoring and control from mobile phones. All of these features support your peace of mind, knowing that the equipment is functioning around the clock with direct evidence of PFAS destruction, so that you have confidence in meeting site compliance requirements.
The PFASigator is highly energy efficient and scales well when included in a recirculating process flow with other technologies that separate and concentrate the PFAS. Using an example of PFAS-contaminated groundwater, the energy-efficient recirculating process flow works like this. PFAS-contaminated groundwater enters the separation and concentration unit where PFAS is removed. The discharge from this stage is the system effluent that meets your PFAS discharge goals. The PFAS that was removed is now concentrated into a smaller volume of liquid, and that concentrate goes to the PFASigator for 1 to 2 orders of magnitude PFAS destruction. At high concentrations, PFAS destruction is highly efficient. When PFASigator has met your site-specific PFAS destruction targets, the liquid is discharged and returned to the separation and concentration unit, where any remaining PFAS is reconcentrated along with the groundwater flow. And I'll further add some data here from our 2023 pilot test at an industrial facility in Michigan, where we treated PFAS contaminated groundwater continuously for 1 month. PFOS was the target compound, and it was at a concentration of 1,600 ppt in groundwater. 5,800 gallons per day were pumped into a foam fractionation unit for separation and concentration. The system discharge met the site-specific criteria of 28 ppt PFOS. Then 12 gallons per day of concentrate were generated with 380,000 ppt PFOS, and that went to the PFASigator for destruction of up to 99.7%. The remaining PFAS were recycled back to foam fractionation for reprocessing with incoming groundwater. And here's a photo of this field pilot in action. On the left are the stacked tanks of contaminated groundwater. This water flowed to the foam fractionation device shown in the back of the room. You can see the foam stacking up in the tower there. When the concentrated foam collapsed back into a liquid, it was then routed to the PFASigator for destruction. That's on the right-hand side of the photo. Following destruction, the PFASigator effluent was then looped back to the holding tanks of contaminated groundwater for reconcentration, and the loop continued. And here's some of the data from that pilot test. Several treatment batches are shown on this slide. Each set of bars represents PFOS concentration in PFASigator influent, the blue bars, and effluent, the orange bars. The right-hand axis shows the percent PFOS destruction achieved. For these batches, that range from 87% to over 99% destruction. One of the advantages of our PFASigator and photoactivated reductive defluorination is that the PFAS destruction occurs at atmospheric temperatures and pressure. So we can have this ion selective electrode on the equipment monitoring the production of fluoride in real time. So we're basically monitoring the destruction of PFAS by the release of fluoride ions into solution. Taking this one step further, you're looking at an example of the fluorine mass balance we're able to achieve using our technology. The left-hand column is all of the fluorine bound to different forms of PFAS before the reaction began. The blue line is the fluoride measured in solution as it was liberated from the PFAS. And the right-hand bar shows the small amount of PFAS remaining after treatment and how well that balances with the fluoride released during destruction. By accounted for the fluorine before and after treatment, we are assured that no PFAS was lost during treatment to venting or sticking to machine parts or other potential loss mechanisms.
So the project Sarah just described was a field pilot with a low flow rate that required only intermittent use of the PFASigator. In contrast, drinking water, water reclamation, municipal wastewater facilities can have flow rates in the millions of gallons per day. Often, these sites use filtration media to remove PFAS from water. With recent commercial availability of regenerable media, PFAS in the liquid regenerate can be destroyed in the PFASigator, with the PFASigator effluent looping back to the filtration media. So to answer the question we often hear, what flow rate can the PFASigator treat? The answer is unique for each site based on a number of variables. However, a general guide is that a single PFASigator module can treat 150 to 200 gallons of site concentrate per day. And then, depending on the technology you used for PFAS separation and concentration, this can equate to 150,000 to 5 million gallons per day for one modular PFASigator. Enspired has also developed a novel approach for fire truck decontamination. The PFASigator is connected in a recirculation loop with the AFFF tank and piping. The fire system is continually flushed with warm water containing surfactant, while PFAS is simultaneously destroyed. When fluoride is no longer being produced, the solution that has been circulating can be passed through a filter media as a final polish and released to a local water treatment facility. This process has been demonstrated to remove and destroy more than 15 times the PFAS removed by a plain water rinse. The advantages to this approach include minimum fire truck downtime, simultaneous cleaning and destruction, no waste left on site, and PFAS removal is maximized while rebound is minimized. All of this is done with a process that meets or exceeds existing guidelines.
PFASigator's reductive defluorination approach itself has many advantages, such as those presented on this slide. We've talked about how it achieves low energy use. And one of the ways we do that is by using what we call a tunable reaction. That is, when the UV lamp is turned off, the destruction reaction stops, and you save energy that might be used to destroy everything in the site water. Here you're only targeting what needs to be destroyed based on your requirements. The technology produces no toxic byproducts. It's safe to operate. It operates at atmospheric temperature and pressure, and you can operate it yourself. Has a modular design with a small footprint, so you can add more units with higher volumes for treatment. It is built of familiar water treatment equipment that has been in the industry and tested for years. It is not a black box that requires somebody from Enspired to operate. And it's automated with remote data monitoring. Again, this offers that peace of mind, even while you're not standing right next to the machine watching it run. If the PFASigator and photoactivated reductive defluorination sound like they might be a fit for you, determining the following characteristics of your site will prepare you for your next conversation with Enspired Solutions. Water matrix. What is the water matrix you're working with? Is it landfill leachate, municipal wastewater, drinking water, or something else? The flow rate. How much PFAS contaminated water are you managing daily? The concentration. What is your approximate concentration of PFAS in the water matrix? And discharge criteria. What are the site-specific regulatory criteria that you are striving to meet? With this information, we can get started on understanding how our technology can apply to your water.
So once you provide the basic information Sarah just described, Enspired can support you in developing and implementing a site-specific strategy. Screening tests demonstrate that this chemistry works in your water matrix. Treatability studies determine the scale of equipment you'll need to meet your site goals. And field pilot and full-scale implementation solve your PFAS challenges on site. When you're ready to develop and implement a site-specific strategy, Enspired is ready to do that with you. Thank you everyone again for spending a bit of time listening today. And now we have some time left to address your questions. Sarah, what kinds of questions are you seeing?
Yeah, Denise, I'm gonna read a few here, and please feel free to continue entering your questions into the chat. Let's see. This is an anonymous question. Would I buy or lease your equipment, and do you provide an operator?
Enspired can use either model. Whatever is the best business decision for you, you can purchase a PFASigator module or you can lease it, and we will assist with installation and train an operator so that you can operate it yourself. If it's a short-term lease and you would prefer that we would operate, then that's a viable option also.
And what makes your technology energy efficient?
One of the big gains we have in energy efficiency are that because we're not heating and pressurizing water, we're not like fighting the thermodynamics of water. We don't have to put all of that energy in. The energy is translated quite directly from the ultraviolet light to excite an electron donor, which provides an electron which reacts to break the carbon-fluorine bonds. So it's energy input directly towards the outcome that we're trying to achieve, gives us efficiency. In addition, in the beginning, I talked about how we form that reactive cage or isolate the PFAS molecules from water. So even when your solution is concentrated, we further concentrate it into these molecular reactive cages. And by having the density of the chemicals that need to react for the breakdown, we gain further energy efficiency there.
Thanks, Denise. Moving on here, are PFASigators currently available? And what is the lead time on PFASigator orders?
Yes, PFASigators are currently available. The lead time on them is 8 to 12 weeks. Generally, by the time we start the conversation with you, a screening test and maybe a treatability test, and then work your engineers or the engineers you hire, and we can advise how to fit it into your system, we can have one ready when you're ready to install it.
And can you treat low transmissivity solutions?
We can, in fact. There is some engineering in the way the PFASigator functions as a batch reactor that allows us to treat low transmissivity solutions. We have had success treating a solution with transmissivity as low as 0.1% transmissivity of 254 nanometer light, UV light.
This one, Denise, I think you covered pretty well in some slides, but it may be worth summarizing. Can you scale up to large water volumes?
Yes. So there's multiple approaches to that. And in fact, I think I have a slide that could help. It's a combination. Scaling up is a combination of both the modular aspect of the PFASigator and the separation and concentration technology that is the best fit for your site. If you use regenerable filter media, you can get concentration factors in the tens of thousands to 100,000 fold concentration, which means you reduce the volume that goes to the PFASigator by 10,000 or 100,000. So as you can see in this slide, if you have a low flow system and you achieve a relatively easy low concentration factor, you might need one PFASigator. You can do a medium flow with a medium concentration and need two. You can do a very high flow with even not the highest concentration, and you're going to start needing more PFASigators. At that point, a custom installation can be warranted, or you can bump this up by another 10-fold and drop back down to one PFASigator.
Great. Here's a quick one. Do you treat solids?
No, we do not treat solids. There can be some suspension in the solution that goes into the batch reactor, but we do not yet treat solids.
And this is a common question. What information do you need to estimate the cost for PFAS destruction at one of my sites?
That goes back to the questions Sarah presented. It really is as simple as these 4 pieces of information here. So water matrix, flow rate, PFAS concentration, estimated within an order of magnitude, and what your site-specific discharge is. With that, we can do a very rough estimate of the total cost. After completion of a treatability test, we can do a very refined estimate. That treatability test gives us the kinetics of how quick the breakdown occurs, what ultraviolet light dose is necessary to break down the PFAS in your water matrix to meet the criteria you're trying to meet.
Thanks, Denise. There's a question here. Will this presentation be available for review after the webinar? Yes, I believe this is being recorded, and we'll leave the distribution of that to Atlantium, but yes, this will be available for viewing after.
Correct. We will send the recording to all participants that were registered.
Perfect. Thanks, Itzhak. Here's one. This is from Stefan. Are there any constraints regarding the destruction when it comes to the length of PFAS molecule?
No, there are not. However, every PFAS molecule that has a standard that we have tested, we have been able to destroy. And there are multiple scientific publications showing that this chemistry can take long PFAS molecules all the way down to complete mineralization. That does require a high UV dose, but there is no limit that we've found yet. It will start on long chains and get them sequentially shorter until they're gone, or it'll start on a short chain and break that down sequentially until it is fully mineralized.
We've got some good questions.
Yeah, production of the fluoride helps greatly with being able to demonstrate that level of destruction.
The next one I'm seeing here, this is from Mariella. What factors in the composition of the water enhance the process of PFAS destruction? Or, for example, high PFAS concentration, TOC content, TSS. Also, what enhances and what has a negative effect on the process?
Excellent question. Thanks, Mariana. The concentration of PFAS, the destruction of the PFAS is more energy efficient at high concentrations. This is a chemical reaction. It's a first order chemical reaction. Let me see if I have a slide to that effect. I think that I do not, unfortunately. What that means is for the same amount of ultraviolet light energy input, you get an order of magnitude decrease in PFAS concentrations. So it costs the same energy, or that equates to money, to go from 10,000 ppm to 1,000 ppm as it does to go from 10 ppt to 1 ppt. You can see in the first scenario, you destroy a whole lot more mass. So you are much more energy efficient at higher PFAS concentrations. That's why the engineering design of looping back and reconcentrating is the most energy efficient approach. We have not found, there are things like transmissivity. We talked earlier. Yes, we treat it in very low transmissivity. As it gets that low, you do lose some energy efficiency. The one thing we have found that in some scenarios disrupts our chemistry is very high salinity, or expressed as TDS. And by very high, I mean ocean level. So salinity in 3 to 4%, or TDS at 30,000 ppm, we have found that some samples with that level of salinity TDS interferes significantly with our chemistry. And that's why the initial screening test, which is a free test where you send us a liter of your water matrix, is something we do. We simply measure, do we produce fluoride? And that lets us know if there's anything unique in your matrix that interferes with our chemistry.
Here's another one. I can probably address this one. How is the concentrated water formed and what technology do you use? This is, there are multiple technologies in the market that can form this concentrate. We've used multiple vendors for foam fractionation. That was in the pilot test example I gave earlier. We've used these regenerable resins or sorbents and treated the backwash concentrate from those. Other things like membranes, RO can also do the job. What you're looking for is a technology that can concentrate over 1,000-fold, 10,000-fold, like Denise is mentioning. The higher the concentration coming into the PFASigator, the more efficient the destruction is. So there are multiple technologies out there that can do that.
And to be specific, Inspired Solutions, we provide one Lego in your water treatment system, the PFASigator, the destruction of the PFAS. So each site, it's going to be different what separation and concentration mechanism is the right fit for your site. If you're not going to be drinking it, you don't need to be concerned about water being drinking level and the concentration technology being NSF approved. So we will work with you, your engineers, or outside engineers, and we do have experience with quite a few, as Sarah mentioned, different separation and treatment technologies, but those are not services provided directly by Inspired other than the strategic discussion to help you figure out what might be best for your site.
Here's one, Denise, it sort of dovetails with an earlier question. Do you have data covering a wide range of PFAS, or is it focused on the main PFAS of note in the industry, PFOA, PFOS, Gen X, etc.? Specifically, short chains are a growing concern, and there's an issue with those potentially being released from thermal treatment.
Yeah, thanks for that question. We do have quite a bit of data on a wide range of PFAS contaminants. Here's an example. This was a groundwater foam fractionate, and you can see they're grouped here as the carboxylic acids, the sulfonic acids, others, PFAS precursors, and even down at this far end, the unidentifiable PFAS precursors. So when this reaction was started, the concentrations were where these blue bars are. And you can see some of them were as high as 14 ppm. The unidentifiable precursors themselves were at 4 ppm. When we chose to stop this reaction, remember we said it's tunable. We could have stopped it earlier. We could have let it run longer. When we chose to stop this reaction, you can see how compounds were dropping by orders of magnitudes throughout all of the PFAS, types of PFAS measured.
Great. Here's a common question. What would be the costs, life cycle, and maintenance costs for the system? Denise, I think I can take that one as well. So the capital cost for the PFASigator really depends on your site, but on the order of $300,000 to $800,000 for one PFASigator, and that would be sized properly for your situation. The life cycle it's built for a 15-year lifespan, and I believe if you do routine maintenance on it, you could make it last even longer. If you were to see the PFASigator in person and realize it's an assembly of recognizable water treatment equipment that we've put together to optimize our destruction reaction. So as long as we keep those parts operating, you've got a working PFASigator there. Now we've priced systems to including CapEx and OpEx, for multiple customers, and we've determined costs per gallon of concentrate to be in the range of $2 per gallon of concentrate to $8 per gallon of concentrate. And that would include both the capital purchase price plus the annual maintenance costs and the reagent costs for the unit and the energy use.
Yeah, I'll add to that energy because that is a standout. When you look at some of the other destruction technologies that we mentioned are fighting the thermodynamics of water, the fact that cost range that Sarah just estimated we've seen for real systems we've worked with includes energy.
Thanks for that question. Here's another one. I may not do the name justice. Coimine Cannell, thanks for the question. Has your firm looked at the destruction of other problematic halogenated hydrocarbons such as dioxins and furans?
Not yet. We are very eager to work on a site that has those. Theoretically, any molecule that will be concentrated in the reactive cage that our reagents create, that micelle formation, will be reductively destroyed also. So yes, that's a possibility. We do not know the full extent of it yet.
Here's another one. This is from Michael Casso. Can you discuss the energy usage and the chemical usage? Is the chemical proprietary?
Yes, the chemicals are proprietary. The effluent from the PFASigator can be entirely non-toxic. The energy usage, we sell our PFASigator in 3 sizes. So the kilowatt of HOD UV light energy is proportional to the amount of concentrated solution it can treat in a day. And so we have a machine that has a 2 kilowatt HOD UV, 7 kilowatt, and 14 kilowatt HOD UV. And the 14 kilowatt can treat, that's the 150 to 200 gallons of site concentrate a day as a general rule.
Here's one from April Haynes. I think I could take this one, Denise. Do you offer initial testing to determine if PFAS is in groundwater or wastewater? So we are not an analytical lab. We actually send our work out to a third-party lab to confirm PFAS concentrations. What we can do in our lab in terms of initial testing is to begin our destruction reaction and watch the release of fluoride ions. This would give us an idea of how much PFAS is reacting in the solution. We don't do the third-party analytical that maybe you're asking about here, April.
As part of a treatability study, that is the first step. We send out a sample to a third-party EPA certified laboratory to analyze PFAS in the sample. And then we begin the reaction and take multiple time points, sending each of those time points out for analysis, along with continuously collecting the fluoride, so that we can really understand the kinetics of the PFAS destruction of the various PFAS compounds in your solution. And then that's the information that can tell us how to scale it to meet your site goals. And worth noting, I don't know that we said it, that's when regulations, which are quite dynamic right now, as they continue to change, if they get more stringent, you can run a batch longer, destroy more PFAS, and destroy it to increasingly shorter chains until there's none detectable, if you want to treat it that far, or you can back off and treat just to the level to meet your requirements. And as always, with the looping back scenario, you get the greatest energy efficiency. But that tunability where you can treat longer, and if necessary, add another PFASigator module, really makes it quite adaptable to the the regulatory environment right now.
Let's see. We've got, I think we have like 2 minutes left here. I guess I'm seeing some questions that are repeated. And sorry for the radio silence here while I'm looking. Here's one. This is from Stephen Grease. Is the destruction pH dependent? And Denise, maybe you could fold into that how our technology compares to other technologies.
Oh, hey, great idea. So the destruction is, I'll say, not pH dependent in the fact that this chemical reaction we've tested and will occur from pH 3 to pH 13. We haven't tested 2 and 14 for safety reasons and unnecessary. So it is more beneficial to be at pH 9, 10, maybe even 11. And the PFASigator can be set to adjust the pH of the batch that comes in and also adjust it back when it leaves the PFASigator as necessary on site for whatever the site-specific criteria is and for the position the PFASigator is in your full water treatment train. So there are advantages that a lot of different destruction technologies are finding with more efficient PFAS destruction at elevated pHs. So other technologies, we are more energy efficient because of what I said than a lot of them, not fighting the thermodynamics of water. We don't heat, we don't pressurize. That saves energy, and it also creates a system that is safe to operate. Hence, we can train you to be the operators of a PFASigator that you can choose to purchase. We do not have toxic byproducts that can often be generated in the processes of oxidation. This is a chemical reduction reaction. And by nature of that, the fluorine, when it's broken off the molecule, becomes fluoride, non-toxic fluoride ions in solution that we can directly measure and are non-toxic relative to hydrogen fluoride gas or hydrofluoric acid. Let's see, energy efficient, non-toxic, safe, automated, fully automated. This will run 24/7. When we help you install it at your site, we optimize it for your flow, and then you turn it on and you let it go if that's the way you'd like to operate it, and all the data and any alarms if something seems out of range can be handled on a computer or a cell phone.
Thanks, Denise. Could you put your slides back to the QA slide? And I'll just point out that we have the QR code there to contact us further. I believe we've come up to the end of our scheduled time here. One last thing I'll say is that there was a question about where do we manufacture our units. They're manufactured right at our lab and offices in Lansing, Michigan. We're in the US. We're a women-owned, certified WeBank and WOSB company. We're very proud of that. You can reach us by scanning the QR code on this Q&A panel here. Denise, any last comments?
No, thank you. I'm really excited to have conversations with everybody about how this might be a match for them and help solve some of your PFAS challenges. Thanks again for your time.
Thank you, Denise and Sarah. Thank you, everyone, for your time. It's interesting to see how hot this issue is. We have here hundreds of participants. For further information, please reach out to us and we will be glad to assist. Have a nice day.